India produces over 2.5 billion pairs of shoes a year, making it the second largest footwear manufacturer on Earth. This massive manufacturing engine directly employs over 4.4 million people. This massive output is rooted in centuries of local craftsmanship. Highly specialized regional products like these Kolakori sandals have helped build an export market that consistently pulls in nearly $5 billion a year. But processing that much rawhide requires immense volumes of water and harsh chemicals. In historic tanning hubs like Kolkata and Kanpur, thousands of unorganized tanneries have operated for decades by discharging untreated wastewater and chemical runoff directly into local canals, creating a severe environmental and health crisis. Major international fashion and luxury brands are no longer ignoring this pollution. Facing direct pressure from environmentally conscious consumers, these buyers are now mandating strict, eco-friendly supply chains. If suppliers can't prove they are operating sustainably, their global contracts disappear. India is now racing against an economic clock. If the country cannot overhaul its manufacturing practices to meet global environmental standards, it risks the collapse of a multi-billion-dollar export empire and the livelihoods of millions of workers. To stop the pollution without shutting down the industry, the government is backing centralized mega-facilities like the Ranatek Common Effluent Treatment Plant in Tamil Nadu. It processes the toxic effluent from 92 separate tanneries at once. The goal of a facility like this is zero liquid discharge. Instead of dumping wastewater, the plant runs the toxic effluent through a rigorous reverse osmosis filter. This separates the harsh chemicals into a solid block of waste and loops the purified water right back to the tanneries to be used again. Reverse osmosis requires forcing water through microscopic membranes at extremely high pressure. Generating that pressure requires a massive amount of electricity. For many tanneries, the energy bills alone wipe out their profit margins, making environmental compliance too expensive to maintain. The solution to this energy bottleneck is a specific piece of hardware installed directly into the pipe network: the Energy Recovery Pressure Exchanger. Rather than letting the pressurized waste stream simply flow out and waste its kinetic energy, this device captures it. A freely spinning rotor inside the cylinder takes the high pressure from the outgoing brine and transfers it directly to the incoming feed water. The incoming water gets pressurized without needing an electrical pump to do all the work. By recycling physical pressure instead of generating it from scratch, the Ranipet facility drops their energy footprint by over 1 million kilowatt-hours a year. That cuts their operating costs by about $70,000 annually. Sustainable engineering shifts green technology from a regulatory hurdle into a primary driver of operational profit. By cutting utility costs at the source, modernized tanneries gain a concrete competitive edge over traditional manufacturers. With reliable, sustainable infrastructure in place, the region is drawing intense foreign direct investment. Global contract manufacturing heavyweights like Taiwan's Fengte and Apache are establishing massive operational bases in India. These aren't small workshops. A single factory in this new wave of development employs upwards of 11,000 people and rolls out roughly 1 million pairs of shoes every single month. Scaling up to this level requires moving away from the hazardous manual labor of the past. Modern facilities rely on automated machinery and robotics to handle hide preparation, drying, and finishing, reducing human error and ensuring uniform quality across millions of units. To operate this equipment, the workforce is undergoing a massive upgrade. Institutions like the Central Leather Research Institute are actively training workers to use computer-aided design software and AI-driven quality inspection systems. On the factory floor, Internet of Things sensors continuously monitor temperature, humidity, and precise chemical dosing in real time, feeding data back to predictive algorithms that stop defects before they happen. International brands are moving into India to tap into this technical specialization. The strategic transition of 4.5 million workers into digital design and machine operation has created a workforce capable of meeting the precision requirements of the high-end global market. This chart shows the projected growth of the Indian footwear and leather industry. Backed by a 1,700 crore rupee government development program, the sector is targeting $50 billion in annual turnover by 2030. Reaching that number means looking beyond animal hides entirely. Startups are already attracting major capital by cultivating collagen proteins and mushroom mycelium to grow biofabricated leather in a lab, mimicking the exact durability and texture of traditional hides. Manufacturers are combining these materials with circular economy models, reusing scraps, and recovering salt from wastewater. They are also implementing blockchain ledgers, so consumers can track their shoes all the way back to an ethically sourced, zero-waste origin. It's an aggressive pivot that attempts to preserve centuries of Indian craftsmanship while stripping away the toxic environmental baggage that historically came with it. Through reverse osmosis, pressure exchange technology, and a massive upskilling of its workforce, India is cleaning up its supply chain. In doing so, it provides a blueprint for how heavy, legacy industries can modernize, protect their environments, and secure their place in the global economy.